Alright, this is part one of our review of graphing rational functions. Rational functions are functions that are made up of fractions, like polynomial fractions. Alright, I'm going to skip around a little bit in a way that makes more sense to me. I like to start with a vertical asymptote. You can get the vertical asymptote by looking at the denominator and setting it equal to 0. Vertical asymptotes happen because you can't divide by 0. So in other words, x plus 8 cannot equal 0, right? We'd be dividing by 0. But subtracting 8 from both sides, that means that x cannot equal negative 8. So that is the vertical asymptote. I guess we should go ahead and we won't put x cannot equal negative 8. For the vertical asymptote, we'll just say the vertical asymptote is x equals negative 8. Alright, which by the way is a vertical line at negative 8. Alright, so there it is. Now, let's talk about the horizontal asymptote. Remember, these are the rules for what the horizontal asymptote will be. It's all about the degree of the numerator compared with the degree of the denominator. If the degree of the numerator is less, then the horizontal asymptote will be y equals 0, the x-axis. If the degree of the numerator and the denominator are equal, then the horizontal asymptote will be y equals a over c, where a and c are leading coefficients, sort of like if we had this, it would be a over c right here. And finally, the degree if the degree of the numerator is greater than the degree of the denominator, then there will be no horizontal asymptote, though there might still be a slant asymptote. So keep that in mind as you look at this. The degree of the numerator is 0, alright, because this is like x to the 0 power. The degree of the denominator is 1. So the degree of the denominator is higher, and so that is the situation where the horizontal asymptote is y equals 0, the x-axis. Alright, so there's your horizontal asymptote as well. Now, slant asymptote. Well, you're either going to have a horizontal asymptote or a slant asymptote, but you can't have both. So if there's a horizontal asymptote, you can forget about the slant asymptote. Alright, but just for future reference, you know how I said there will be no horizontal asymptote if the degree of the numerator is greater than the degree of the denominator. Well, that's true. So if there's no horizontal asymptote, there might be a slant asymptote. And that will happen if the degree of the numerator is exactly 1 greater than the denominator. For example, this is x to the 3rd power. So imagine that we had x to the 2nd power down here. Now the degree of the numerator is 1 more than the denominator. There will be a slant asymptote. And we will find that by doing long division and looking at the non-remainder part. Okay, but not on this problem. Will there be any holes? Well, holes happen when you have a factor in the numerator and the denominator that cancels out. So for example, I'm just making this up, but say if I had x plus 5 over x minus 7, and I had the x plus 5 was times x minus 3, and the x minus 7 was times x minus 3. Well, I would wind up canceling out these x minus 3's. But now there would be a hole at x equals 3. Okay, so when a factor cancels out completely, it doesn't give you a vertical asymptote, but it will give me a hole. And I'm going to want the x value and the y value, so I would have to plug this 3 back into the function, the original function, and see what I get as a y value. Anyway, there's nothing canceling out on this problem, so there are no holes. So we'll just say none. Alright, in general, if you want to find the x-intercept, let me slide over here. If you want the x-intercept, you can get it by letting y equal 0. If you want the y-intercept, you let x equal 0. Alright, see how it's the opposite? So I want the x-intercept, so I could get that if I let y equal 0. Well, this f of x over here is like y. Alright, so if I went ahead and solved this, let's see what would happen. Well, you know what? I'm going to get something that's basically undefined is what's going to happen. Alright, let me just recopy this up here. So I have 0 is equal to 2 over x plus 8. One of our usual moves would be to multiply both sides by x plus 8. Alright, but if I do that, the x plus 8 cancel each other out. 0 times x plus 8 is 0. So this is going to give us 0 equals 2. Well, that's a problem because 0 does not equal 2. Alright, so it's trying to tell you that there is no x-intercept. Okay, with a rational function, another way to think about it is with rare exceptions, you can just look at it and set the numerator equal to 0. You know, so if this were 2x, I would set 2x equal to 0, and that would help me find the x-intercepts, you know, which would be 0 in that case. But there is no x there. So all I have is 2 equals 0, which is a ludicrous statement. 2 does not equal 0. And again, that means that there is no x-intercept. Now, anyway, on to the y-intercept. For the y-intercept, we let x be 0. In other words, we plug in 0 and see what we get. Okay, so if I put 0 in for x, then this becomes 2 over 8, which becomes 1/4. Okay, so the y-intercept is the y-intercept, so it's the y value that is 1/4. Okay, of course the x value is 0. Now, we want increasing and decreasing intervals. Oh, I guess I got to graph it first. Alright, to go any further, I need to actually do the graph. So it would be helpful. We need to make a table of values. Okay. I need to definitely get some values to the left and to the right of this vertical asymptote. So let's do, for example, -10. See what's going on there. Let's do -9 for sure. And maybe even -8.5. I like to get the decimals in there to see what's happening. Okay, and on the other side, I'm going to do -7.5, which is close in. And probably, let's do -7 itself. And -6. Alright, so that should be plenty to work with. Alright, to get these values, I am going to put the original function in my calculator. Okay, so 2 over x plus 8. Okay, TI-30 XS multi-view. Let's quit out of this. Let's get into table mode, clear this out. So I saw it was 2 over x plus 8. Okay, so now I can get whatever values I want. Alright, where shall we start? Let's start at -10. Alright, at negative 10, we're at negative 1. Negative 9, negative 2. I'll have to do the decimal part later. Now, negative 7. Negative 7 is 2. Negative 6 is 1. Okay, now let's go back and get those decimals I wanted. I wanted negative 8.5. Okay, one way to do it is hit the table function, hit enter, and type it in. Okay, at negative 8.5, I'm at negative 4. How about negative 7.5? At negative 7.5, I'm at positive 4. Alright, now let's graph these points and see what we're dealing with. So, negative 10, we're at negative 1. And negative 9, we're at negative 2. Negative 8.5, we're at negative 4. Okay, that gives us a pretty clear picture of what's happening. Now on the other side, negative 7.5, okay, we're at 4. Negative 7, we are at 2. And negative 6, we are at 1. So we can see the two branches. All we have to do is draw the curve. Okay, so approaching the asymptotes on either end, your graph should look something like this. So now we can answer the rest of the questions. The domain is the x values. So you can see the graph goes to the right forever and it goes to the left forever, but it skips over the vertical asymptote. Okay, so we're going to have to actually say the domain in two parts, the part to the left and the part to the right of negative 8. Alright, so the domain will be from negative infinity, okay, to negative 8, union, and then we'll pick up from there and say negative 8 to infinity. Okay, so again in the picture we're just trying to skip over the vertical asymptotes. So from negative infinity to negative 8, and then from negative 8 to infinity. Alright, we can mention negative 8 because we use round parentheses to show that the negative 8 is not actually included. Alright, and of course it can't be because there's an asymptote there. Now the range is the y value, so we're going to do pretty much the same thing, but this time we're going to skip over the y, the horizontal asymptote, which is at 0. So the range will be from negative infinity to 0, and then from 0 to positive infinity, y values. Okay. Oh, now increasing and decreasing intervals. Now we can go ahead and do this. So this branch over here, from left to right, it's decreasing the whole time. Alright, so from negative infinity all the way up to negative 8. Alright, we're talking only x values. So negative infinity to negative 8, that thing was decreasing. Okay, so negative infinity to negative 8. Alright, I'm keeping it round because it doesn't reach negative 8. Now the other branch is also decreasing because it sort of jumps and starts up high and then it goes down, down, down. Okay, so that is going to be from negative 8 to infinity. That's a decreasing. Again. Okay, there are no increasing intervals. It's decreasing the whole branch and decreasing the whole other branch. So increasing interval, none. There were none. Okay, did I get everything associated with this problem? Alright, I think that was it. Alright, I'm jumping around too much now. That was it for problem number 1. Okay, and that's long enough for a video even. Alright, that's a 15 minutes, so I'm going to stop this video here, and we will start the next video with another function to graph. I'll see you on the next video. Make sure, please make sure you're not copying off of me. Alright, if the video is playing, your pencil is down. See you on the next video.